Welcome to the start of our Pendulum Inquiry Lab. This part of the lab we're going to focus on the introduction of the lab, which really includes three different things. It includes writing the background information, writing a question, and writing a hypothesis. All that's lumped together into what we call the introduction of a lab. And your lab's going to be about a pendulum. A pendulum is basically any mass or a weight that's hung by a string or a rope or some other object that can pivot back and forth. It pivots on what's called the fulcrum. And so the pendulum basically just swings. For example, if we start here, it would swing over to here and then back again. You're going to be doing your investigation using the pendulum as your guide, and again today we're going to be focusing on the background information. To help you get started with the Pendulum Lab, what you need to do is download the handouts from the web page that help you get started with the introduction of your lab. And when you do so, one of the pages you're going to be looking at is the page you see in front of you right now that says Reading to Help with Background Information. So what we're going to do is write the background info of your lab, and this reading, at least in part, is going to help you to do that. To help you organize your thoughts on the reading, I put together some Cornell notes that you can use to read the handout and then answer the questions over here. And then eventually you'll put these questions together into a paragraph that will become your background information for the lab. Not everything is found easily in the reading, so let me just go over a few things that might be helpful. And I tried to indicate where you could find the information. For example, what is a pendulum? You can find that in the reading. Also, doing a YouTube or Google search for this would be helpful, especially if you weren't here when we practiced using the pendulum the first day. And then also, how can a pendulum be used to figure out that the Earth turns? Actually, pendulums can help us figure out that the Earth is spinning. It's evidence that the Earth is spinning. If you don't understand the reading section in this, again, Google it or YouTube it will help a lot. Examples of a pendulum, same thing, Google it and read it. And I want to talk about 4 and 5 together in just a minute. And then finally what we're going to want to do is come up with a research question and hypothesis for your lab. And I'll help you with that in a second as well. So I want to focus on question 4 and 5. What is the period of a pendulum? And how do you plan to calculate that for the lab? So I'm going to minimize this screen here and focus on those two questions in particular. So I'm on question 4 and 5. So first of all, what is the period of a pendulum? If this is the fulcrum of the pendulum and you pulled the pendulum back, here's the bob of the pendulum, and you let it swing out like this, and I'll draw a dotted line here to represent the string being over here, and you also let the pendulum swing back to its original spot. So you let it swing back to this spot right here. That motion all the way down and all the way back to its original spot, the time it takes for it to do that, so the time for one complete swing is called the period. So time for one swing or one oscillation is equal to the period. Now there's a couple ways you could calculate that. One way is literally you could just let go of the pendulum, start a stopwatch, let it swing there, let it swing back, stop your stopwatch. The problem with one swing is that it can be really difficult to time it just right to not have very many errors, because there's a lot of errors just starting and stopping your stopwatch. So this is actually now the answer to question 5. The solution most kids came up with in class was let it swing back and forth 10 times. So that'd be 1, 2, 3, etc. I won't go all the way to 10, but you let it go 10 times and time it for that 10 times, and you would end up with something like this. If you let it go back and forth for 10 times, let's say you got 20 seconds, and you let it swing back and forth for 10 swings, you would divide those and be able to figure out the time for one swing. So it's basically 2 seconds for every one swing, or in other words, we would say a period of 2. So this pendulum had a period of 2 in my example. Okay, and then finally, once you've done your basic research on what pendulums are and filled out the Cornell notes to this point, what you're going to focus on is coming up with a research question. Of course, you know to come up with a research question, you need to know what your manipulated and responding variable is going to be. Sort of hinted to it already, but a good responding variable for a pendulum lab is probably the period, the time it takes for one complete swing. So I'm going to go ahead and assume that you've made the period your responding variable. And now what kinds of things might be manipulated variables that might affect the period of the pendulum, or how quickly it swings back and forth? So let's brainstorm a few possible ideas. In class, students experimented and tried to figure out their own manipulated variable, and we'll just discuss 3 quick ones that students came up with. One variable that students came up with potentially changing is just the length of the string of the pendulum. So some students, maybe they have like 40 centimeter string length, and then they make another one that's a little shorter, and another one that's a little shorter, and another one that's a little shorter, and maybe even another one that's a little shorter. So in this example, the student would have picked 5 different string lengths. So they have 5 experimental groups, and they'll test the period for each one of those. And then they could write their research question: to what extent does the blah 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 blah. I'm not going to answer that for you. And you come up with your hypothesis and why you think that. So that's a perfectly legitimate experiment or manipulated variable, length of string. Now, the other thing you might choose to do sorry for the delay there. The other thing you might choose to do there is, instead of length of string, you might choose to change the mass in the pendulum. We're actually using film canisters, which are hollow containers that we used to store film in back in the day, back when we used film. And you can easily drop things into the film canister, like nuts and bolts. So let's say you drop a bolt in your film canister. That could represent one mass. And then maybe in another pendulum you add 2 bolts, so you're increasing the mass of the pendulum this way, and so on forth. And maybe in this one you have 3 bolts or some other substance to add mass to the pendulum. And I'm only showing 3 here, but you might end up having 5 experimental groups again, or maybe even 6 or 7 if you have time for that. And again, you'd be looking to see how that might affect the period of the pendulum. And finally, what we can do, we could also change the angle we drop the pendulum at. Is another great thing that you could change. So maybe on 1 you pull the pendulum all the way out to a 90-degree angle and let it fall, and calculate the period back and forth. On another one, maybe you only drop it at 60 degrees, from 60. And another one you might choose to drop from even a less angle, maybe 45 degrees, etc. Maybe another one you choose to drop at 25 degrees, and so on and so forth. So you change the angle of the drop. It's another thing you could test to see if that affects the period of a pendulum. And once you've done the Cornell notes, decided what your manipulated and responding variable are going to be, what you're going to do is you're going to take that information in the Cornell notes, and you're going to write the background information of the introduction of your lab. And I expect your best writing, complete sentences, well thought out, and anything you write here should stand alone. You shouldn't need the questions in the Cornell notes to figure out what you wrote here. And you would explain a little bit about pendulums, and then you would tell us your manipulated responding variable, write your research question and your hypothesis, and why you wrote your hypothesis here. There's a rubric for grading, and you're welcome to check that out on the downloaded handout. You have to get a 4 or higher to pass by the state of Oregon. Anything below that would be considered not passing. And this is only the first section of your lab. There are 4 total sections, and if you get a 3 or lower on any one of the sections, you don't pass the entire lab, unfortunately. To make this compatible with my grade book, I gave this many points that you'll get in your grade book for each thing. And then the last thing I want to say is you can type all this up. I did include a handout on the website. You could download that, and instead of turning it in handwritten on the page I just showed previously, you could type it instead, which I would prefer, and that would be this first section of your lab finished. I hope that helps you get started with your Pendulum Inquiry Lab.